Welcome to Converse of Pythagorean theorem. So Pythagorean theorem states if a triangle is a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Right? Basically it says if the triangle is right, then c squared equals a squared plus b squared, where c is the longest side. The converse flips the if and the then. The converse states if the squares of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. In other words, if c squared equals a squared plus b squared, then triangle is right. So before, you were given a right triangle and asked to find a missing side. Now, you're giving all the sides, but you're asked to determine if the triangle is right. Let's take a look at a little bit more. So, converse of the Pythagorean theorem, if the square of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. All right, so you're not going to know whether the triangle is a right triangle. You're going to determine it by taking the c squared and what's c? C is the longest side. So look at your side measures. Whichever is the largest number, that's going to be c. Right? And so your long squared is equal to side squared plus side squared. If that is true, then the triangle is a right triangle. Right, so here's an example. Tell whether the triangle is a right triangle. Right, so we have three sides, 7, 24, and 25. 25 is bigger than 7 and 24. That's the longest side. All right, so we're going to substitute that for c. All right, so 25 squared equals 7 squared plus 24 squared. All right, 25 squared is 625. 7 squared is 49. 24 squared is 576. 49 plus 576 is equal to 625, and we see that c squared does indeed equal a squared plus b squared. So therefore, triangle DEF is a right triangle because Pythagorean theorem holds. So if Pythagorean theorem is true, if we set it up with the longest side squared equaling the sum of the other two sides squared, and we get a true statement, then the triangle must be a right triangle. Now, not only can we determine if a triangle is a right triangle or not, we can use that same theorem to classify whether a triangle is acute, obtuse, or right. So if the square of the longest side of a triangle is greater than the sum of the squares of the other two sides, then the triangle is obtuse. And that would make sense because a larger angle is going to be opposite a longer side. So if c squared is greater than a squared plus b squared, then triangle ABC is obtuse. And conversely, if the square of the longest side of a triangle is less than the sum of the squares of the other two sides, then the triangle is acute. And that makes sense, because a smaller angle will be opposite a smaller side. So if c squared is less than a squared plus b squared, then triangle ABC is acute. But could any three measurements, create a triangle? Let's take a look at that. Can segments with lengths of 2.8 feet, 3.2 feet, and 4.2 feet form a triangle? If so, would the triangle be acute, right, or obtuse? So here we didn't even draw a triangle out, but that's okay. As long as we have the measurements, we can still check. But first, let's see if it's a triangle. To see if it's a triangle, we're going to use another theorem called triangle inequality theorem. And I do have this in your notes. and I'll show you where I have it in a summary page. So we're going to use, so this particular problem is not in your notes, but the summary is. So we're going to use the triangle inequality theorem to check the segments can make a triangle. And here's what triangle inequality theorem says. Now it's called inequality theorem because we need something to be greater than something else. Specifically, we need the sum of the two smaller sides to be greater than the larger side. If that's true, then triangle inequality theorem will be true. So triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. The one that's going to mess it up is the largest side, if it could be messed up. So here we checked with all the sides. So we added each pair of sides and checked to see if it was longer, if that sum was greater than the third side. All right, so here we checked with the two smallest sides, 2.8 plus 3.2. They add up to 6, and 6 is greater than the third side. All right, so that one was true. The sum of the lengths of those two sides was greater than the third side. What if we add up 2.8 and 4.2? What if we add up those two sides? All right, well, 2.8 plus 4.2, that's 7. And 7 is greater than the third side, which is 3.2. So that one checked out. What if we add the two longest sides, 3.2 and 4.2? Would that be greater than the smallest side? Well, of course. 3.2 plus 4.2 is 7.4, and that is greater than 2.8. So if we add up any two sides, it has to be greater than the third side. So you notice that we get the smallest sum here when we add up the two smallest sides. Right? So let's check with the two smallest sides for the rest of the problems. Because if that one works, the other two will work, right? Because we're going to be adding up larger sides. So now let's check to see if it is indeed what kind of triangle it is. All right, so we're going to classify the triangle by comparing the length of the longest side with the sum of the squares of the lengths of the two shorter sides. In other words, long squared equals side squared plus side squared. So all we have to do is identify which is the largest side. All right, so the largest side was 4.2. So 4.2 squared. All right, we don't know whether it's going to be equal, less than, or greater than until we calculate it out. So that's why I put a question mark there. So we're using Pythagorean theorem, 4.2 squared. Who knows? 2.8 squared plus 3.2 squared. All right, so 4.2 squared is 17.64. 2.8 squared is 7.84, and 3.2 squared is 10.24. All right, so now we're going to check to see if 17.64 is less than, greater than, or equal to 7.84 plus 10.24. When we add up 7.84 and 10.24, we get 18.08. So since 17.64 is less than 18.08, in other words, c squared is less than a squared plus b squared, the triangle is going to be acute. So if c squared is less than a squared plus b squared, we have an acute triangle. If c squared is equal to a squared plus b squared, we have a right triangle. And if c squared is greater than a squared plus b squared, we have an obtuse triangle. And c is always whatever the longest side is. So now this one is in your notes without the multiple choice. Right? It's okay, we don't need the multiple choice part. And we're going to first of all determine if this is a triangle, and then we're going to determine what kind of triangle it is. So step one, let's use triangle inequality theorem. All right, and we're just going to check that the longest side is less than the sum of the other two sides. Because if this one works out, the rest of them are going to work out. All right, so the longest side here is 15. That's our C. And so 15, is that less than 12 plus 11? I'll put a little question mark here. All right, so 12 plus 11, that's 23. and 15 is indeed less than 23. So this is a triangle. All right, that would make a triangle. So second, now let's classify using Pythagorean theorem. If you need to abbreviate, that's fine. So long as you have the basic information in. All right, so our longest side is 15. So is 15 squared, right? What's that going to be compared to 12 squared plus 11 squared? All right, so 15 squared is 225. 12 squared is 144. 11 squared is 121. If we add those two together, we get, and actually I'm going to take the question mark out because now we're going to be able to put something in there. We get 265. Well, 225 is less than 265. So since c squared is less than a squared plus b squared, the triangle is acute. All right? So we have determined it's a triangle by using triangle inequality theorem, and we have classified this as an acute triangle using Pythagorean theorem, and we've justified our answer. All right? So if I ask you to justify your, so you have problems like this in your homework, and I ask you to justify, right? This statement here would be fine, right? Since c squared is less than a squared plus b squared, the triangle has to be acute. Let's try another one. All right, so we want to, first of all, determine whether or not this is a triangle. So we're going to use triangle inequality theorem. And we're checking that c is less than a plus b. All right, and so c, we got 3, 5, and 6. 6 is our c because that is the largest side. All right, so we have 6, which is it going to be? We're going to add up the others. Well, 3 plus 5 is 8, and 6 is indeed less than 8. The figure is a triangle. Now let's use Pythagorean theorem to classify. All right, so we have c is, so it's going to be long squared, and I'll put a question mark here, side squared plus side squared. All right, so our long side is 6, so 6 squared, who knows? 3 squared plus 5 squared. 6 squared is 36. 3 squared is 9. 5 squared is 25. 9 plus 25 is 34. 36 is greater than 34. So since c squared is greater than a squared plus b squared, the triangle is obtuse. Right? We've used triangle inequality theorem to check that we have a triangle. We use Pythagorean theorem to classify, and we've justified our answer. Let's try another one. All right, so first of all, let's check to see, is this a triangle? So we're going to use triangle inequality theorem. Now, in your notes, if you want to write that once, you know, step 1, use triangle inequality theorem. Step 2, and then we're checking that C is less than A plus B. If you want to write that once at the top, that's fine. Of course, I tell you now that we're on the third problem, but all right, so we got 7, 24, and 25. 25 is the greatest value there. So 25 is C. All right, so we have 25. Who knows? 7 plus 24. Well, I do know because this is more than 1. This is going to be a triangle. And 25 is indeed less than 31. So really, I had 24. If my side was 2, it'd still be a triangle because 26 would be greater than 25. But just trying to be precise when we notate things. All right, so now let's use Pythagorean theorem to classify. And I'll write out Pythagorean. Right, and we're using C squared, and we're checking which it is, A squared plus B squared. Oh, excuse me. Let me use not C's, A's, and B's. Long squared, which is it going to be? Side squared plus side squared. All right, so 25 was the largest side, so 25 squared, question mark, 7 squared plus 24 squared. 25 squared is 625. 7 squared is 49. 24 squared is 576. If we add those up, 49 plus 576 is 625. So those two are equal. And if you might have actually remembered from the previous video on Pythagorean triples that 7, 24, 25 was a Pythagorean triple. So then, if you knew it was a Pythagorean triple, you could also justify it that way. So 625 does indeed equal 625. For this lesson, I would like you to use the Pythagorean theorem to justify. I won't give you too many right triangles anyway. 625 does equal 625, so since C squared equals A squared plus B squared, the triangle is right. All right, so we have our answer. We've determined it, justified it. We're all good. All right, I think I got just a couple more for you. All right, and by the way, if I go too fast and you're not able to keep up with notes, remember you can always rewind me. All right, let's look at another one. All right, so let's try this one. All right, so we've got 5, 15, and 3. All right, so 15 is the long side. That's going to be C. All right, so we're going to, first of all, use triangle inequality theorem. To determine if this is a triangle. And we're checking that C is less than A plus B. All right, so 15, what's it going to be? 3 plus 5. Well, I don't think it's going to take you very long to figure out that 15 is not less than. It's greater than 8. So, since C is greater than A plus B, these measures do not form a triangle. This is not a triangle. Maybe I'll write out the word triangle. No way, Jose. All right, so I actually measured, there's a ruler up here. I did this before I recorded because, well, I tried doing it while I recorded and the ruler was just being a pain. It never wanted to go where I wanted it to go. So I previously recorded on here the ruler markings. So I measured out, this is 15, and this happens to be, using the ruler that there is up here, this was 15 centimeters. So maybe it's 15 centimeters when you look it on a screen. I don't know. And this one was the 3 centimeters, and this is the 5 centimeters. Or, so you can see, here's the ruler. So I don't know what that is. I guess that's just blown up. So relative to the inches up there, that would be centimeters. So you can see here that poor little 3 and 5 is never going to reach the 15. Nope. Right? They just collapse. They're not going to reach each other. Right? They're trying, but they can't. So not a triangle. So we can't classify not a triangle. We're done. This one is not in your notes. All right, so let's determine whether these represent the sides of an acute, right, or obtuse triangle. I would never give you something like this and ask you to determine if it's a triangle, because, well, I guess you could take the square root of 3 and get a decimal equivalent so you can add it up. I will tell you that it does make a triangle. Now, you might wonder which of these is the larger side. All right, well, I know that the square root of 4 equals 2, and the square root of 9 equals 3. Therefore, the square root of 3 is the smallest side. So you don't have to worry about him. This, of course, is the largest side. That's our C. All right, so we're just going to step 1 here. We're going to use Pythagorean theorem to classify. All right, so, and that's long squared. What's it going to be? Side squared plus side squared. Boy, just squeeze that in. Although I lost my parentheses. All right, so 3 squared, which is it going to be? 2 squared plus the square root of 3 squared. So that's 9. 4, and of course we learned how to square radicals. The square and the radical cancel each other. That's just going to be 3. Right? And so 9 is greater than 7. So since c squared is greater than a squared plus b squared, the triangle is obtuse. And there we go. That's all it takes to classify triangles, or to determine if 3 numbers could possibly make a triangle. All right, so a little review. And this is all in your notes, including the part that says add to your notes. I added it to your notes already. All right, so this is a nice summary that you have. I think part of it's on one side, part of it's on the other side, that goes with the problems that you had to do in your notes. So if c squared is equal to a squared plus b squared, then the triangle is right. If c squared is greater than a squared plus b squared, then the triangle is obtuse. If c squared is less than a squared plus b squared, then the triangle is acute. And c, remember, is the longest side. If c is greater than a plus b, then a plus b plus c does not make a triangle. Triangle inequality theorem states that c has got to be less than a plus b to be a triangle. The longest side has to be smaller than the sum of the other 2 sides. Otherwise, the other 2 sides can't reach each other. Okay? And that's all there is to the converse of Pythagorean theorem. Thanks for watching, and bye for now.